In this video, I want to cover the chain rule. Chain rule is one of the most important derivative rules that we use. It has to do with a function inside of a function, when we have a composite function. Here we have f of g of x. The way we do this is you take the derivative of the outside function first. I'm going to take the derivative of f, which is f prime. I rewrite the inner function, and then I'm going to times it by the derivative of the inside function, which is g prime of x. It's most widely, I shouldn't say that, but it's used a lot with trig functions. For example, let's say we had the y equals sine of 3x. The outside function is sine of x. I take the derivative of that. I rewrite the inner function. Whatever it is, you just write it, but then you multiply it by the derivative of the inner piece, which is 3. We end up with 3 cosine of 3x. You'll notice the notation here on the trig functions. Going forward, this is how I want you to write it. The derivative with respect to x of sine of u. This forces you to use the chain rule. The outer function is sine, you write cosine, of the inner function, then it's times u prime. Cosine is negative sine times u prime. Tangent is secant squared. This should not be negative. Cosecant minus cosecant cotan times u prime, and then times u prime. Remember, all the cofunctions are negative. And then same thing for e to the x. We're going to see things of this nature, e to the 2x. Same process though. To find the derivative, you rewrite the function, you times it by ln of the base, and then you times it by the derivative of the exponent. For something like this, we would get 2e to the 2x. Here we have deriving ln of x. So these are things you have to start memorizing, guys. It's a lot, but this, you can think of it as, I like this one, u prime over u. Derivative of ln of x is just 1 over x. Derivative of ln of x is 1 over x. But you can think of it as the derivative of the inside over the function. The derivative of x is 1, you get 1 over x. If we had ln of 2x, it's u prime over u. U prime is 2 over 2x, which reduces down to 1 over x. And then these are all ones that you should memorize. You should really just memorize it in terms of u. That's the most common. These are the same thing, but this is just applying that chain rule to it. This is what I was talking about earlier. When it's e to the x, or e to the u, we can say now, e to the u, you rewrite it. It's ln of the base times u prime. Well, what if it's not e? Let's say the base is 2 or 3 or 4 or 10. We rewrite it, so you get a to the u, ln of the base times the derivative of the exponent. And then the last thing is for a log. Derivative of a log will be u prime over ln of a times this should be a u. Yeah, because it's u prime over, it's similar to ln of x. So up here you could think of this as u prime over u times ln of the base, but base is e, that's why we don't write it. Where here you have u prime over u, but then it's ln of the base, so ln of a. It's helpful for memorization. I get it, e to the x is easy, but when we write ln of e, yeah, we don't really write it, but it's helpful to remember it when you do other bases. Same thing with log. It's u prime over u divided by ln of e. Yeah, we don't write that, but it's helpful when you have a log that's not base e. So there's a lot going on here. I highly recommend you memorize these as we go, because we're just going to keep adding to it. Number 1, find the derivative. This would be something where we don't want to have to FOIL this out 4 times and then take the derivative. You could do it, but chain rule will work. So this is how it works with an exponent. Y prime, the outer function is the 4th power. We're going to bring down the 4th power. You can almost think of it like this. It's something to the 4th power. We bring this down, we rewrite it, we lower the power by 1. Same thing. The only difference is that thing is not just x, it's 2 minus x cubed. So we bring down the 4, we rewrite it, we lower the power by 1, but now we have to take the derivative of the inside, which is negative 3x squared. Y prime, I could do this times this, we get negative 12x squared, 2 minus x cubed. For number 2, we're going to multiply the 2/3, rewrite the inside, lower the power by 1, times derivative of the inside. We get 6 over 9t plus 2 to the 1/3 power. For square roots, we want to make sure that we rewrite it as an exponent. We have 4 minus 3x squared to the 1/2 power. We're going to apply the chain rule, bring down the 1/2, rewrite it, lower the power by 1 times the derivative of the inside. We can simplify. For number 4, so we can do this as the chain rule. This is what I was talking about. Sometimes with a quotient rule, you can put it as a product rule if you know the chain rule. We couldn't do it earlier because we didn't know the chain rule. But you could really write this as y equals 4 minus 5x minus x squared to the negative 1st power, dy dx. I'm going to bring down the minus 1, rewrite the inside, lower the power by 1, times derivative of the inside. So I've got negative 1 on top, negative 5 minus 2x, and then over 4 minus 5x minus x squared squared. You'll notice if you remember the product rule, it's low d high, high d low over bottom squared. Notice this is the bottom and it ended up being squared. So you can do it either way. You can do product rule or you can rewrite it and do the chain rule. For number 5, we've got a chain rule with a product rule. So I will do this off to the side. This is going to require a lot of space. Let me do it up here. Number 5, we've got f of x equal to x 2x minus 5 cubed. It's first times derivative of the second. Derivative of the second will be 3 2x minus 5 squared. So I bring down the 3, rewrite it, lower the power by 1, derivative of the inside. That's first over the second plus the second times derivative of the first. That one wasn't too bad. F prime, I could simplify from the inside to start with. We could just do 6x 2x minus 5 squared plus 2x minus 5 cubed. That one wasn't too bad. I'm fine with you leaving it like that. You definitely do not have to factor out a 2x minus 5, but if you did, let me show you how to do it, just in case it ever was a multiple choice question. So this is common to both of them. In fact, there's 2 common to both of them. So we can take out 2x minus 5 squared and then times what you're left with. We're left with 6x plus 2x minus 5, like that. And I could combine like terms to get 2x minus 5 squared, and then 8x minus 5. For number 6, I'm going to again do that down here. I don't know that I'm going to work through this whole thing. 6 is a lot, but let's get it started. H of t, we've got t squared over t cubed plus 2 squared. So first this is chain rule, but then to do the derivative of the inside, it is quotient rule. Let's give it a try. H prime of t, bring down the 2. We rewrite it. Lower the power by 1, then times the derivative of the inside. So that will require low d high minus high d low all over the bottom squared. And just for time purposes here, I'm going to leave this, but what could we do? We could simplify in here, and multiply the 2t squared to the top, and we can make this t cubed plus 2 to the third power, because remember, this is to the first power here, and we can put the bottoms together for that one. But moving along here, now notice the difference between 7 and 8. This is really important. Number 8 was this. This is very common for chain rule. You would be expected to know how to do this. Y equals secant squared of x. You would rewrite it as the top. Y equals secant of x squared. That's everything squared. Then we could do chain rule. We get y prime, bring down the 2, rewrite the inside, lower the power by 1, derivative of the inside, which is secant x tan of x, and then we can simplify it to get 2 secant squared of x tan of x. For number 7, the only thing that's squared is the x squared. I would rewrite this as secant of x squared. Makes it a little bit easier because we've done things where we've just done sine of 2x. Derivative of secant is secant tan. It's secant of x squared tan of x squared, but then times it by the inside, which is 2x. Y prime, we're going to get 2x secant of x squared tangent of x squared. And then for number 9, the outside function is sine. Derivative of sine is cosine of this function times the derivative of the inside. Don't be fooled by that. Pi is a constant. Pi goes to 0. F prime of x is equal to cosine x minus pi. Again, oops. For e to the x, remember, we rewrite it. So the rule for e to the x is this. You rewrite it. ln of the base, ln of b, and then derivative of the exponent. That's why e to the x is just simply e to the x when you derive it. Because we rewrite it, derivative of the exponent is 1, ln of e is also 1. Now we have a function in the exponent. We rewrite it, ln of the base, ln of e goes away, and then times negative 2x. You get negative 2x e to the negative x squared. That's g prime. This one's a little tricky. What I would probably do, rewrite it like this. Now, that's just the angle measurement. It's no different than cosine of 2x. We have y prime equals cosine is negative sine of the inside. pi squared x squared times derivative of the inside. Now how do we find the derivative? This is a constant, so it's 2 times pi squared x. Let's go over that again. Pi squared x squared. You take the exponent of the variable, times it by the constant, 2 pi squared x, lower the power by 1. For this one, I would rewrite it. It looks like that. Like that. So the 2 goes over the whole thing. We bring down the 2. You rewrite it. Derivative of the inside, derivative of cosine is negative sine of pi x, and then the derivative of that, which is pi. So this is where the chain rule gets fun. You start with the outer function, you bring it down, you rewrite it. Derivative of the inside has 2 parts now. We have cosine, and then once we do the cosine, we have pi x. We can clean this up a little bit to say negative 2 pi cosine of pi x sine of pi x. For 13, I'm going to rewrite it, h of t, and we get 2 cotangent pi t plus 2 squared. I'm going to put brackets there. I think I'm actually just going to leave the 2 out till the end and multiply it by 2. It's not going to make a difference, but I'm going to leave it off. H prime of t, bring down the 2. So I'm going to assume this is not here right now. Bring down the 2, rewrite it. Times derivative of the inside. Cotangent is minus cosecant cotangent. Then I have the derivative of that times pi. So h prime of t, remember I had that original 2, so 4 with a minus pi. So I took care of that, 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 and then I would just rewrite the rest of it. You could do 2 of these, I guess. Cotangent squared pi t plus 2. And I have cosecant pi t plus 2. Okay. For number 14, let's work it off to the side. So for 14, again, this is a little confusing, but we have sine of x to the 1/3 power. The 1/3 is just going to the x plus the sine of x to the 1/3 power. Although they're both chain rule, on the first one, this is the outer function, that's the inner function. This is the outer function, and this becomes the inner function. For the first one, y prime, derivative of sine is cosine. It's cosine of, I'll just say cubed root of x. Then I have to times it by the derivative of the inside. 1/3 x to the negative 2/3. Plus 1/3 sine of x, lower the power by 1, negative 2/3, times derivative of the inside cosine of x. You get cosine of x to the 1/3 over 3x to the 2/3 plus cosine x over 3 sine of x to the 2/3. I would not attempt to simplify that. Okay, if you got that far, hats off to you. For number 15, let's get this one set up. I need to rewrite this. Cosine, sine, tan of pi x. This one's tricky because, remember, when you write cosine of, usually it's an x, or pi over 6. This is the angle measurement. The angle measurement for this is everything else, okay? So it makes it really confusing. You're going to start with the outer function. The outer function is cosine. It's negative sine of all of that. Sine of tan of pi x. All I did was this, which is the outer function of the inside. Then I start working the inside. Then I'm going to times it by the derivative of the inside, which is here. Cosine of tan of pi x times it by the derivative of the inside. Tangent is secant squared. I'm going to wrap it around down here. Secant squared of pi x, and then times it by pi, the derivative of that. I'm going to leave it like that. We could obviously bring the pi up and put it there, but I wouldn't even attempt to simplify this, okay? And then for the last one, we've got a product rule. First times derivative of the second plus the second times derivative of the first. You have negative e to the negative x times x squared. All I did was move out the negative. Then plus, I guess I could put the x in front, 2x e to the negative x. Okay, for the next page, I want to jump to number 20. If we want to derive ln, it is u prime over u. It's the derivative of the inside over the function. So this would just be 4x over 2x squared plus 3. Pretty easy to do. If you look at number 17, you can definitely do u prime, the derivative of what's in the parentheses. You can definitely do u prime over u, but think about that for a minute. To do u prime, you would have to do quotient rule, and then you'd have to put it over the function, which is another fraction. When you have something this complicated with a log, we can expand it. So hopefully you can recognize that. You can do it the long way. It works, 100%. I put this on a test once. I had a student take up the whole page, and they did it correctly, using u prime over u. But if you expand this, we can write y equals, remember for logs, when it's division, it's subtraction. When it's multiplication, it's addition. So we can expand it to ln 1 plus e to the x minus ln 1 minus e to the x. Now just treat them as two separate questions. Y prime is u prime over u. U prime over u. And since it's double negative, and I wouldn't worry about getting a common denominator. So the trick is you need to recognize it, because if you spend a lot of time doing this, you can do it. It just takes a lot of work to do that. Okay, number 18 is a product rule. So we have the first derivative of the second plus the second derivative of the first minus e to the x. G prime of x. These would cancel. I get x e to the x for that one. This one's tricky. E cubed is a constant. When you derive it, if it was just this, I've seen this on the AP exam, and you derived it, you just get 0, because it is a constant. Remember what I said, when you have a constant in the front, let's say it's 3 sine of x, write the constant and then find the derivative of the function. I talked about it too with e to the x. If you have 3e to the x, write the function, write the constant, and then derive the function. Same is true here. Write the function, write the constant, keep saying function, write the constant, and then derive the function. We end up with e cubed over x for that one. For 21, we have chain rule. The outer function is the 4, bring it down, 4, rewrite it, lower the power by 1, derivative of the inside. We get 4 ln of x cubed over x for that one. And then for this one, I would rewrite this as ln x squared minus 9 to the 1/2 power. You can do a chain rule here. Okay, you could bring down the half, rewrite it, derivative of the inside. What I would suggest, we talked about when it's division, it's subtraction. When it's multiplication, it's addition. If you remember the power rule, this comes down to the front. Y equals 1/2 ln x squared minus 9. Now when I derive it, I can keep the 1/2 out of it. I just do this, which is u prime over u. So for y prime, u prime would be 2x over x squared minus 9. And I simply multiply by a half. That cancels. You get y prime equals x over x squared minus 9. So for logs, you really want to pay attention. If you can use your properties first, I think it will help you to derive it. Same thing for this one. I'm going to expand it. So I'm going to expand the logs. It's ln of 2x minus ln of x plus 3. I treat them each individually. It's u prime over u, 2 over 2x minus u prime, which is 1 over x plus 3. We get y prime equals 1 over x minus 1 over x plus 3. Write the equation of the tangent line at the given point. Again, more practice with the chain rule, but we're going to bring down f prime. We get 2/3, 9 minus x squared, lower the power by 1, derivative of the inside. I would just plug in from this point. We've got 2/3. I'm plugging in 1. 9 minus 1 is 8 to the negative 1/3 times negative 2. On top, I've got negative 4. Like that and that. On the bottom, we have 3. And then the cube root of 8. 8 to the 1/3 power is the cube root of 8, so 2. I get negative 4 over 6, which is negative 2/3. My equation will be y minus 4, negative 2/3, and then x minus 1. I'm going to jump down to these just for time here. I can start this one. It's a long video. We have y equals tangent, 2 tangent of x cubed. Y prime, you bring it down, you get 6, rewrite it. Lower the power by 1 times derivative of the inside. Tangent is secant squared of x. And we're doing this at pi over 4. With pi over 4 equals x. Y prime. Tangent of pi over 4 is 1. That's nice. So 6. 1 squared. Secant of pi over 4. I'm going to square it. I'm going to use a triangle here. Pi over 4 is 45. Secant goes with cosine, adjacent hypotenuse, so hypotenuse over adjacent, so we get root 2 over 1, which works out nice also. I end up with y prime is 6 times 2. I end up with 12. I do need to double check this, but we get y minus 2 equals 12, and then x minus pi over 4. So down here we have the functions that are not e and not ln. They're not super common, but you do need to know them. They're similar, that's why I think it's important you just understand the formula. Even though it was e to the x, we said e to the x. When we derived it, you rewrite it, ln of the base, and the derivative of the top. So for something like this, we've got g prime of x. There's not much you can do once you write it down. You don't really simplify these much. You rewrite it, times ln of the base, times the derivative of the top. And that's all you can do. So don't even try to combine it. For 27, it's a product rule. You have the first times derivative of the second. You rewrite it, ln of 2 times the negative 6. First over the second plus the second, let me wrap it around here. Second times derivative of the first, which is just the 1. I would just leave it. That's super, super ugly. And then for this one, we've got quotient rule. So it's low d high. Low d high. You rewrite it. ln of 2 times derivative of the exponent. Low d high minus high d low, which is just 1, over the bottom squared. Like that. And again, I would just leave it. For this one, we have log. I think you should expand it, because you're still doing u prime over u. The only difference is we're dividing by ln of 10. But to do u prime, you have to do a quotient rule. So I would expand. Okay. Now this is u prime, which is 2x over u divided by ln of the base. Then it's u prime over u, and then ln of 10. And again, I would not try to simplify. The last one, we have log base 5 of tan of x. It's u prime over u times ln of 5. Derivative of tangent is secant squared. U prime over u times it by the ln of the base.